momentum of the electron. We know that the electron has the spin motion about its own axis. So this spin is always half. So in addition to the orbital motion, the electron has the spin motion. Due to spin motion, of electron, it has spin angular momentum. So quantum mechanically, the spin angular momentum now this Ls equal to square root of S into S plus 1 into H upon 2 pi. Where S equal to spin quantum number. And this S is always equal to half. The spin is always half. For the single electron, the spin value is half. So this spin is never zero. Because of that, this orbital angular momentum for the spin motion is never zero. So Ls equal to square root of 1 by 2 into 1 by 2 plus 1 into H upon 2 pi. So this Ls equal to square root of, this is now root 3 into H upon 4 pi. Because this is now 2 and 2, 4, 4, this is now 2, so this is now H upon 4 pi. So square root of 3. Spin angular momentum is never zero. While orbital angular momentum may be zero. This may be zero. So this Ls, L spin, this is never equal to zero. So this is what the angular momentum possessed by the electron due to its spin motion. So this spin motion is always half, and because of that, we are having this angular momentum. I told you that for s orbital electron, the orbital angular momentum is zero, but this spin angular momentum is not zero. So for any kind of orbit, the electron always have the angular momentum. There may be the orbital angular momentum to be zero, but spin angular momentum is never zero. So because of that, the electron always have the angular momentum when it is moving, and also it is having the spin about its own axis. So thank you very much.